Okay, this is going to be the last video on how to do problems that involve integration using partial fractions. And in this video, we'll look for the first time at a problem that requires you to do long division as the first step of the problem. Now, first of all, how do you know whether you need to use long division or not? And it has to do with the original rational function. So if the degree of the denominator is greater than the degree of the numerator, then you do not have to use long division. It would be a proper fraction. But if the degree of the numerator is greater than or equal to the degree of the denominator, then you have an improper fraction. And before you can split it up into partial fractions, you have to use long division first. And let's take a quick look at the steps just to remind you. This is from previous videos. We use these steps to decompose the function. And that first step has always been, if the original rational function is improper, which means the degree of the numerator is greater than or equal to the degree of the denominator, then you have an improper fraction, and in the first step you've got to divide using long division to break it up into a proper fraction. So we'll do that in this step. So let's take a look at this back to our original problem now. What we've got is this. So the degree of the numerator is x squared, the degree of the denominator is x squared, so we will have to use long division here. So what we're going to do is just set it up as this. And this is just same old long division that you've always had back in algebra. So I'll take the denominator, which would be x squared plus 6x plus 9. And I'm going to divide it into the numerator. So we'll go over here and make it be, say, this right here. Okay, so we'll rewrite the numerator here. Now I've got a 2x squared plus 7x, and just to hold the constant, I'm going to put a plus 0 just to hold the place for the constant. Okay, to divide this, just using your algebra rules, so ask yourself, what do you have to multiply x squared by to get 2x squared, and you have to multiply it by 2, so you have a 2 right here, and then 2 times this gives you 2x squared, then 2 times this gives you plus 12x, and finally, 2 times 9 gives you a plus 18. And you'll have that. Then what I usually do is put parentheses around it and change it to subtraction. This will give you 0. This would be 7 minus 12, which would be minus 5x. And finally, this becomes negative 18. 0 minus 18 would be negative 18. Now, since x squared won't go into 5x, that's actually going to be the remainder. So this is going to be, it'll break down into 2 plus, and actually, in this case, it's going to be a remainder of this thing over this thing. So this would be minus 5x minus 18 divided by x squared plus 6x plus 9. So that's the long division, and you've taken this rational function and changed it into this form right here. So let's go ahead and rewrite that up here. This would be equal to, then, it's going to be the integral, and you've got the constant 2, then plus, and this is minus 5x minus 18 divided by, now this is x squared plus 6x plus 9, which will actually factor into x plus 3 times x plus 3. So this actually becomes x plus 3 quantity squared. And I think I'll go ahead and write that like this. So we'll put it in this form and make this be x plus 3 squared dx. So the first step is to use long division and to rewrite it as a proper fraction. Now, actually, this really splits it into two parts. You'll have the integral of 2, which will be easy to calculate, but you'll still have to use partial fractions to do this part of it right here. So let's go ahead and rewrite things. In this case, this is going to be the integral of 2, so we can leave this one alone, but let's concentrate just on this and break this down using decomposition into partial fractions. So what that's going to look like, and we'll go ahead and put it right here, I'll have minus 5x minus 18, and this is exactly the same steps that we've used in previous problems. And then I'm going to have an x plus 3 squared. And this is going to be equal to, now again, what this is, it's a linear factor that's repeated twice. So again, using our rules here, it's going to fall in this form right here. So you'll have this term plus this term because it's been repeated twice. So back to our problem. This would be, first of all, you've got the first x plus 3. Then you've got plus, and because it's repeated twice, this one's going to be x plus 3 and squared. Now this is going to be a, and this is going to be b, using decomposition just like in the previous problems. Okay, now the next step, you need to get rid of the denominator on these, and as we've done in the previous problems, we'll multiply through by the common denominator to eliminate the denominators. So we'll multiply this one by x plus 3 squared. We'll multiply this one by x plus 3 squared, and this one by x plus 3 squared. So multiply through to get rid of the common denominator. And again, we'll move things down just a little bit. Okay, now when you do this one, these two will cancel out. So the x plus 3 squared here cancels out the x plus 3 squared here, and leaves you with minus 5x minus 18. And that's equal to, now here, this x plus 3 will cancel out one of these x plus 3's, but not both of them. So this one will cancel out this, and it'll leave you with a times an x plus 3. And then finally, on this one, x plus 3 squared, these will cancel out completely and just leave you with a b. So what this is going to be, just like in those previous videos, this is going to be the basic equation that we'll use to determine a and b. So we'll go ahead and put a little box around this just to kind of isolate it here. So that's going to be our basic equation. So again, just like in the previous videos, now the next question is what is a and what is b? And we'll use the same tricks that we used before. The idea is to pick a value of x that will make one of these terms go to 0, and you can solve for the remaining term. So in this case, the first thing we'll do, we'll go ahead and find b, because if we let x be a negative 3, then this term will go to 0, and we can solve for b. So the first step here will be to do this. To find b, you'll let x be equal to, and again, whatever it takes to make this thing go to 0. So if you let x be a negative 3, those will cancel out, so we're going to let x be a negative 3. So again, just like before, go ahead and everywhere you've got an x, replace it with a negative 3. So this becomes minus 5 times a negative 3 minus 18 is equal to, and then I've got a times a negative 3 plus 3, and then plus b. Now the reason I picked that negative 3 is because negative 3 plus 3, that'll go to 0. This entire term will go to 0, and in effect, it just disappears. So this is going to give you a positive 15 minus 18 is equal to, and it just turns out to be b. And that will give you negative 3 is equal to b, and now you have the value of b. So the next question is, what is a? So again, we'll kind of follow the same process. Now, to find a, you can't let b, there's no x value to put here. So the idea is just now that you know the value of b, you can pick any value of x that you want to, except negative 3, and you can use that to solve for a. So now we'll do this. We'll make this be to find the value of a. And this time, we're going to let b be a negative 3, and you can pick any convenient x that you want to, other than negative 3. So in this case, I think I'm just going to pick 1. 1 seems like a pretty easy number. You could pick a different number if you wanted to, but I'll pick 1. So this is going to become minus 5 times 1 minus 18 is equal to a times 1 plus 3. And then b is a negative 3. So let's run through this. This is going to give you a negative 23 is equal to, this would be a times 4, and this is going to be minus 3. So go ahead and add 3 to both sides, and you'd have negative 20 is equal to 4a, and then if you divided, you'd have negative 5 is equal to a. So now you know A, and now you know B. And what that will do, we'll go back up here, and I think I'll put them right here, is A, you now know, is equal to a -5, and B is equal to a -3. So you can replace that with a -3. So you can break this fraction down into these two. So -5 over x plus 3 and -3 over x plus 3 squared. So now what we'll do is go back up to the beginning, and we're just going to replace this with, in its expanded form where we've decomposed it into partial fractions. So what that would look like, let's go ahead and scoot on back down here. That's going to be, we'll write it right here. So this is going to be the integral of the original thing would be equal to, well, I think I'll write it one more time. So this would be 2 plus, and this was a -5x minus 18 divided by x plus 3 squared dx. And again, what that is, that's just, we'll go back up here, that's just this original problem. And we'll write it now in its expanded form, which would look like this. We'll make this be the integral of, and we'll split it up into 3 separate integrals. It'll be the integral of this one, which would be 2 dx, plus, and this one we'll put in this form right here. So -5 over x plus 3, and then -3 over x plus 3 squared. So that's going to be the integral of -5 over x plus 3 dx. And then finally, you can make the last one as an integral of -3 over x plus 3 squared. And again, this is exactly how we've done them in the previous video. So if you're a little unfamiliar with this, look at the previous videos and they'll explain this in a little bit more detail. Okay, now it's just a matter of solving each one of these separately. So this is just a power rule. This one's going to be pretty easy. We'll write it right here. So integral of 2 dx. Then I've got plus. Now what this one's going to be, I'll bring the -5 out in front. This would be the integral of 1 over x plus 3 dx. And then finally this one would be plus, say, and I'll bring the -3 out in front and make this be -3 times the integral. And I'm going to take this and move it up to the numerator and make it be x plus 3 to the -2 power. And I can actually use a power rule on that one. So to solve these, now this one is just good old power rule. So we'll write them as 3 separate things. So the antiderivative of this one would be 2x. Then the antiderivative of this one. Now what this is, just a reminder, this is going to use one of the rules that we've had before. And that rule looks like this. It's just 1 over u is equal to the natural log of u. So we've got 1 over this. And since this is a simple x, you don't have to use u substitution. So here's the constant -5. And so you've got a -5 here. And then this will turn into natural log of the absolute value of this, x plus 3. And then there'd be a plus c here. Then you've got this last one. Well, the last one is -3, and the antiderivative of this would be x plus 3 to the -1 divided by -1, and then we'll combine the plus c, plus c, plus c, all these pluses into one constant right out here on the end. And the last step now is just to write it in the final form. So first of all, the integral of the first part gave you 2x. The integral of the second part gave you this, so -5 times the natural log of the absolute value of x plus 3. And then finally in this last part, this 2 negatives, that'll turn into a positive 3, so plus 3. And I think I'll do this, since this is x plus 3 to the -1, move it back down to the bottom, make it be the positive 1, so that would be like having 1 over x plus 3. And then finally you've got a plus c out here on the end. So the final answer is going to look like that. So really the only thing that's a little bit different in this problem was to where you had to do the long division first. So let's move back up at the top. And again, because the degree in the numerator is either greater than or equal to the degree in the denominator, you had to do this long division step first to break it up. This would be an improper fraction, and by doing this, you broke it up into, in this part, a proper fraction. And then just treat them as two separate problems. Find the integral of 2 on its own, and then you have to use partial fractions on this part. So again, we use partial fractions the same way that we've done in all the previous videos to figure out what the values of a and b are. Then it's just a matter of rewriting the integral as those three parts. There's this part right here was a, this part here was b. Find the antiderivative of each one of those, and you've got the answer. So that's a final problem just to show you one example that required long division as the first step. And then again, just a reminder, that came from this part right here. If the original rational function is improper, divide using long division before you apply partial fractions.